Hello, today we'll try solving this trigonometric equation, which is sin x plus 1 is equal to cos x in the interval from 0 to 2 pi, where 0 is inclusive in the interval and 2 pi is non-inclusive. What we are going to do is bring cos x onto the left and take 1 onto the right. So the equation turns out to be sin x subtract cos x is equal to -1. Now let us square both sides. So squaring both sides will give us sin x minus cos x whole squared is equal to the square of -1. Now this is a minus b whole squared, so which should give you a squared sin square x minus 2ab, so 2 sin x cos x, and plus b square, so plus cos square x, and this is equal to the square of -1, which is a 1. Now you can see over here that we have sin square x plus cos square x, and this is the identity, which is sin square x plus cos square x is equal to 1. So what we can do is, instead of sin square x plus cos square x, we can replace it by 1. And now this equation turns out to be 1 minus 2 sin x cos x is equal to 1. And this now can be simplified as 1 minus 1 is equal to 2 sin x cos x. So 0 is equal to 2 sin x cos x. Now we have the product of these three equal to 0, which means either of them, if it is 0, the equation or the result would turn out to be 0. Now we know that 2 cannot be 0. So one of the possibility is that either sin x can be equal to 0 or cos x could be equal to 0. So now we look for the values of x in this interval where sin x is 0. So if you go by the graph of sin x, so this is how it is. So this is how the graph looks like within a period. So this is 2 pi. Here we have pi. This is pi over 2 and this is 3 pi over 2. So we are looking at the values of sin x being 0. So one possibility is 0 and the other is 2 pi, which is non-inclusive over here. So the only possibility of x from here we get is x is equal to 0. Now let us look into the other one, cos x is equal to 0. So if we draw a graph of cos x, so this is how it looks like for one period. So this is 2 pi, this is pi, this value will be pi over 2 and this is going to be 3 pi over 2. Now you can clearly see that cos pi over 2 is equal to 0 and cos 3 pi over 2 is equal to 0. So the possible values of x over here are x could be pi over 2 or x could be 3 pi over 2. Now, because we have solved this equation by squaring both sides, so we have to look for the extraneous factors over here. So let us check for all these three values that if they satisfy our original equation. So if we try putting the value of x into the original equation, our left side is sin 0 plus 1 and sin 0 is 0 and 0 plus 1 is equal to 1. So our left hand side is 1. Let us look at the right hand side. So for right hand side we have cos 0 and cos 0 is equal to 1. So this value x is equal to 0, it satisfies our original equation. So this is one of the solutions. Now let us check for x equals pi over 2. So for that, our left hand side is sine pi over 2 plus 1. Sine pi over 2 is equal to 1. We can see it over here. And plus 1. So 1 plus 1 is equal to 2. And our right hand side for the original equation is cos pi over 2. But we can see over here that cos pi over 2 is equal to 0. So we can see that the left hand side is not equal to right hand side. So this is not a solution to our given equation. Now let us check for the last one, 3 pi over 2. So keeping that, our left side is sine 3 pi over 2 plus 1, which is equal to sine 3 pi over 2 is negative 1 plus 1, and this is equal to 0, and right hand side will be cos 3 pi over 2, and we can see here that cos 3 pi over 2 is equal to 0. So our left hand side and right hand side are the same. Hence, x equals 3 pi over 2 is another possible solution. So the solutions to this question are x is equal to 0 and 3 pi over 2. I hope you understood the process. See you in the next video. Bye-bye.